Today we are going to discuss about the software-defined network and OpenFlow in brief. So software-defined network is nothing but a newest networking paradigm that actually changing the shift of the network from the hardware to software. So software-defined networking gives you several APIs that gives you control, the programmable control over the hardware switches, over the software switches by some particular APIs. So here is the outline of this presentation, outline of this lecture. First we discuss about a brief about the SDN architecture, then we go through SDN API and one of the most popular SDN API, that is OpenFlow. We discuss about working on OpenFlow switch controllers, and how OpenFlow is also developed in a commercial scale, OpenFlow advantages, disadvantages, and some of the research trends in OpenFlow. So as an introduction, I would like to say that all the legacy networks that we see, the traditional networks, are all hardware based. And since it is hardware based, so everything is vendor dependent. So we can say these are all proprietary devices. And SDN comes on the way to make the network vendor independent, and it provides some openness in the sense that it gives you an API that can enable the software as control over the whole network. So SDN is basically a software as control over the control plane of the network devices. So as you know that your every network device like switches, routers, access points, they have some memory and they have that control plane where actually the network operating system operates on top of. And SDN actually takes advantage of that division of labor in terms of division of functionalities. So SDN suppose the division of the network in 3 layers. First, the application management layer, which lies in for almost most of the layer 7 applications. Next is the control layer, which actually talking about the memory of the switch, router, and any other networking device that is controllable by any other controller. And data layer. So data layer is nothing but the actual hardware seek that is actually responsible for forwarding of the packets. And these layers are actually distinctly divided in SDN, whereas in your traditional network, all these 3 layers are coupled together. Now we discuss which layer does what. So application layer is all about your high-level applications such as traffic engineering, firewall, your security apps, and all the other layer 7 applications that can be run on top of the control layer. And control layer, it basically operates on the memory of the network devices such as switches, wireless access points, routers, etc. The place actually where the software can take control. And since we have the memory, so we have the provision to have the intelligence, but of course in spite of having the intelligence is slow because the processing of the memory takes time. And if we have less memory, then of course it's even slower. So memory requirement in SDN, memory requirement in OpenFlow and other APIs are generally more. In place of the static RAM in traditional switches, we prefer using the ternary content addressable memory, which provides more memory processing than the static RAM. So we're not going into details of the TCAM in this lecture. In data layer is all about, we discussed that it's the hardware seek. We can say that it's only takes care about the forwarding of the packets. So it's basically very fast, but it doesn't have any kind of intelligence. So we can say it's a dumb, but it still is fast. So you can see that there is a speed mismatch between the control layer and data layer, which is supposed to be addressed by all the SDN APIs, and which is one of the challenge while deploying the SDN in large networks. Now talking about the APIs, SDN has two major APIs. One is northbound, that actually enables the communication between the application layer and the control layer, such as your REST API, OpenStack, CloudStack, those kind of cloud-based softwares. And so this basically makes that we can directly signal the control layer from some of the applications running in the application layer. And in doing so, we don't need to intervene directly going to the data layer. So the application layer may or may not directly communicate to the data layer, but it can signal to the control layer first. In southbound API, the communication between the control and the data layer takes place. So it's actually one of the major proportion of SDN actually takes place here in the southbound APIs, such as your OpenFlow, Cisco, Oplex, and OpenFlow. As I told that OpenFlow is one of the most popular APIs that coming with SDN. So SDN API like OpenFlow actually supports the communication between the control and the data layer. So it basically gives you the communication between the memory and the forwarding devices. Now, if we say the control layer, when control layer is also programmable by a network operating system, and this network operating system affects the control layer, and control layer can directly communicate to the data layer. So basically, we are limited to only communication between the control layer and data layer in southbound API. So now we get some detail about the history of OpenFlow. So why we are discussing OpenFlow history before we have discussed about something like something in SDN? Because OpenFlow concept was actually coined first. From this concept of OpenFlow, actually the software-defined networking thing that evolved. So OpenFlow is one of the fast APIs in software-defined network. It was developed in Stanford University in 2009. It came out as the output of a PhD thesis by Professor Martin Casado, now from Stanford University, who worked under the guidance of Professor Nick McKeown from Stanford University. So OpenFlow is all about three things like matching, action, and statistics. Matching basically is done on the headers of the packet. In OpenFlow 1.0, version 1.0, which was released in December 31, 2009, it actually supported the matching of basic fields of layer 2, layer 3, and layer 4. Whereas I would like to mention that the higher versions of OpenFlow, such as version 1.2, 1.3, 1.4, they support even matching of more number of fields than version 1.0. So in version 1.0, in the layer 2 header, we could match source, destination MAC, VLAN ID, VLAN priority, ether type, and ingress port in the layer 2. We can also match in layer 3 the source and destination IP, the type of service pills, which is basically used for the quality of service things, IP protocol. In layer 4, we can match the TCP source and destination port. And in OpenFlow, matching may be either full or wildcard based. When you talk about full matching, that means it enables the matching of the complete entry, the complete header, complete part of the header, the complete field we can match. Suppose we match the complete IP address, then it becomes the full matching. And wildcard matching, basically we are actually matching partial, we are partially matching the field, not matching the complete entity. So like we are matching the first 2 octets of a particular IP address. So more matching fields are, I told that in more matching fields are already available in the newer versions, and version 1.3 supports around 40 match fields. If matching is done, an action follows such as forward, drop, modify, etc. So whenever a matching is successfully done, we can apply some action such as forward, dropping, modification of the flow table. Those can be done. So there are several types of action, and the major types are like forwarding, dropping, and some kind of modification. So now the last part is the statistics. Now if a successful match and action follow, a counter is increased, and this is done to maintain the statistics of the network devices to estimate that actually how many successful match and action is performed. This counter may be kept in terms of bytes or in terms of packets. So how an OpenFlow switch communicates to the OpenFlow controller? Now, as I say that while the switch is having the memory, it should be controlled by a particular network operating system. We can term it as a web controller, means the OpenFlow controller. So OpenFlow controller communicates to the OpenFlow switch using some OpenFlow messages that is encrypted by transport layer security like TLS, and also can be used with SSL. So the channel between the OpenFlow controller and the switch is basically a secure channel. OpenFlow controllers, there are several open source and commercial controllers available nowadays. The open source controller, the popular open source controller like POX, Knox, Ryu, Floodlight, OpenDaylight, and several other controllers are there in the list. And apart from the open source, we also have the commercial OpenFlow controllers like HP DN, Cisco Epic, and there are a few other commercial controllers available for controlling, for acting as an OpenFlow controller. Now, OpenFlow, I'd like to say one thing that OpenFlow, as you know, as I already told, that OpenFlow is the most popular API in SDN, and OpenFlow nowadays comes with almost all the manufactured switches or routers. And most of the big vendors are there actually manufacturing their commercial hardware switches and even the software switches with the support of OpenFlow. And this is some of the list of all the companies there. This is not the only list, there are a few more, but I have just presented some of them. Now, what are the benefits and issues of using SDN or OpenFlow, you can say? The benefits are like that, it can enable the network management in the runtime. So, we don't need to just troubleshooting and all those things. Now, no more to be done like in a static manner, that where we take so much time to detect where the trouble is, where the failure is, and then go for troubleshooting that part. So we don't need to do those kind of hard work right now, and we can just make the network management completely runtime. And runtime means we can control the network in the runtime from the centralized controller, SDN controller. The SDN controller gives us the global view of the network, which helps us to get some idea about the failure, get some idea about the topology changes and all those things. And since it is a centralized software-based control over the network, so it gives us a benefit that we can program our network, we can program the modules, whatever we want to implement in our network. And some issues are of course there, and as I told you that in the earlier slides, that there's a speed mismatch between the data layer and the control layer. So of course there's a problem with scalability. Apart from the speed mismatch, since if we rely on a central controller device, then that may become bottleneck at any point of time. And if it becomes bottleneck, then of course it can also lead to a central point of failure. Now I would like to introduce to some of the few topics that are open for research, and these are not the only list. There are several other topics out there, and I am just mentioning some of these key topics that may be taken for research. Like OpenFlow is basically the motivation of OpenFlow was basically to develop it as a commercial product. So it is basically intended to develop for the data center networks and the cloud networks. In the data center network, the management is very tough, and SDN controller actually can optimize the whole approach by uh, doing so many optimization in terms of routing and all other network functions that are available. SDN and OpenFlow can be also used in campus networks, like the innovation or any kind of changes, any kind of software-based control can be implemented in the campus networks as well. And wireless mobile networks, especially when you talk about the 5G networks and all, SDN takes a big part in that wireless mobile networks at all. In wide area networks, so in wide area network, it is of course very challenging to use the SDN controller because it's a challenge to uh, synchronize the policies, the network policies throughout the routers located in different geographic locations. And of course, I would like to mention that Google is the first to deploy the SDN in the wide area network, and they name it as B4 networks. And in B4 network, they basically uh, have a SDN based control for the inter data center network. SDN can provide the fault tolerance and a reliable control plan, which is actually hard to achieve because fault tolerance is a common feature, but when in terms of the control plan, if the control plan fails, then the whole network will of course fail. So the reliability issue, the fault tolerance issue for the control plan is a big issue for research, I guess, for SDN. So these are the references. If you want to start with the concepts of the SDN, then these are some of the references, and I would like to emphasize that if you start learning the SDN, then you can start with that survey on the software-defined networking that actually Mark read in the slide. You can start with that because this survey paper will give you some brief details about all the insights and all the spectrum of the software-defined network. So with that, I'd like to conclude. So I hope that from this lecture, you will be able to get some idea and get some insight about the basics of the SDN. For further details, you can go with the online resources. You can visit the Open Networking Foundation website, and you can read up those online resources that are available. So I hope that I'll see you again with some new materials for the SDN in future. Thank you.